Well, good morning, pre-calc students. How's everybody doing today? We're going to finish up section 7.6, the polar coordinates. The guided notes are just the same ones from yesterday. We're just going to finish those. A couple problems on the back of that, at the back of the guided notes. Yesterday we plotted polar coordinates, which was something totally different, and then we converted between polar and rectangular, and then we are not in rectangular and polar. We are not going to worry about converting equations. We are not doing that. And then today, we're going to graph polar equations, which I think are super cool. But that's just me. But let's go through that and kind of explain some things here. On the homework wise, the homework key should be posted. Well, it'll be posted later tonight. But here's at least the answers to the evens to make sure you understand what you're doing. Give you an idea, 34 and 36, make sure those are in radians as well. Okay. And then, like I said, for number 10 and 12, I'm not too concerned the order that you put those in, just as long as you have all three representations for those. Okay. So we're on the back of those, that equation, the graph of polar equation. Well, just like anything else, we graph it the same way. We're just going to plot points to begin with to learn about it. But we're going to graph the points on a polar coordinate. Okay, and now it's a little bit different because you're used to like y equals mx plus b and y equals. Polar equations are given in the r equals form, which is a little bit different because where the equations usually, or the points, are given in terms of r theta. We would think it would be theta equals, not for polar equation. It's going to be r equals f theta. Okay, so just a little bit different there. Now that's a set of all points that have at least one polar coordinate that satisfies the equation. Okay, make a table of several ordered pair solutions, plot the points, join them with a smooth curve. Okay, these are all going to be curves for those. All right, here's what we're going to do. Here's that first one. Sketch the graph of the polar coordinate r equals 1 plus cosine of theta. So in this case here, r equals 2 times. Now you can distribute that. I'm not really sure why they have that factored out. So you can make that 2 plus 2 cosine of theta. We are just going to plot the unit circle points. And let's list these first before we actually plot those. Let's list these first set. And just use your calculator. And so just go here. And so what was it? 2 plus 2 cosine of theta. Theta will go into here. And 0 degrees. Well, what is 0 degrees? So sometimes it doesn't hurt to kind of get a mental picture of what the cosine of 0 degrees is. Hopefully you remember cosine of 0 is going to be the x-coordinate is going to be 1. So 2 times 1 is 2 plus 2. That should be 4. But if you do that, 2 plus 2 cosine of 0 degrees, it's going to equal 4. We're going to go ahead and just round anything to the nearest tenth. We're not going to do exact values. We're just going to plug them into the calculator. So what is 2 plus 2 cosine of 30 degrees? Okay, 3.7. What is 2 plus 2 cosine of 45 degrees? And that's 3.4. And then 60 degrees, 2 plus 2 cosine of 60. And I get 3. Now on your calculator, to save a little bit of time, what I can do is if I'm just using the same thing over, I can hit the second and then I can hit the enter button where this says entry there. And it'll pop up the same thing, and then I can just arrow over and make that a 90. And then I get 2. And then I can do the same thing, hit second, entry, make that 120, and I get 1. And then what's the next one? 135. So I got second entry. Whoops. I have to hit second entry. And then that is the same thing. Hold on. Make that 135. And I get 0.6. And then second entry 150. And I get 0. I'll just round that to 0.3. All right, I'm going to pause this. You go ahead and fill in 180, 210, 220. Go ahead and fill in all of them. Got it? And then I'll be back in 1 second. And then we'll finish this off. All right, hopefully you got those all filled in. Pause that. And then I got 0, 0.3, 0.6, 1, 2, 3 for 300. 315 is 3.4, and 330 is 3.7. Now, 360 degrees, I know I don't have it listed as you look at your chart, but I like to put this down as well. But 360 should be exact same thing as 0, okay, because they're equivalent. So that's going to be 4. So that just kind of ties everything together. You can really just go back to 0 degrees, but I just like to have it there. All right, let's graph these. Now, don't forget, our points are in the form r theta. Okay, so these are a little bit backwards. So this is going to be the point 40 degrees. This is the point 3.7, 30 degrees. Okay, and then this is the point 3.4, 45 degrees. Let's plot these. Now, you got in front of you, hopefully you got your table filled in. So 40, let me do this in red. It'll be right there. That has a radius of 40 degrees. The next one is 3.7, 30 degrees. So you're going to have to estimate where 3.7 is. So you go out 1, 2, 3, 3.7, put it right about there. Now the 45 degrees, remember that spoke is not there, okay? So it's going to be 3.4, 45 degrees, just a slightly bit below half. And now I got 60 degrees is a radius of 3, which would be right here. And then 90 degrees is 2, so it's 290. 120. And then 135 degrees is 0.6, which would be right around here. And then 0.3 for 150. And then 180 is 0. Now I'm going to stop right here. Sometimes it's going to be helpful to kind of stop and see what's going on. All right, so what does this look like? These points we would connect with a curve. So you're going to go from 0. See how good I can do that. That's going to be a little bit hard. 30. And then that's going to curl around to 0 degrees right there. So that's going to be that first half of that graph for this equation. Now, this starting at 210. Well, 210 goes back to 0.3. 225 is 0.6. 240 is 1. Then 270 is 2. 300 is 3. 315 is 3.4. 330 is 3.7. And then 360 or 0 is 4. So it goes in and back out. All right, that shape right there, these polar graphs, the shapes have some special names. This is called a cardioid because it looks a little bit like, those of you who are in health tech, it means heart. So it looks a little bit like a heart. So it's called cardioid. You can graph these on your calculator. Let me go through and let me show you how to do this. Okay, but you got to be careful here. says y equals. We have to be in a different mode. And this is going to change our window and everything else. So when you go to mode, go down to the 1, 2, the fourth line. It says FUNC. That means function. PAR means parametric, which we haven't dealt with. POL means polar. We want to go over to polar. Okay, everything else should stay the same. Just go to polar, hit enter. Okay, so that's on there. Now go back to y equals. And it should say r equals, and you probably didn't have an equation in there. All right, it says r equals. And we can type in, what's my equation? 2 plus 2 cosine of theta. 2 plus 2 cosine theta. All right, I'm going to hit graph. And I don't know what's going to happen here, but I'm going to hit graph. That didn't turn out too bad. All right, so a couple things here. Just make sure you understand. Go to window, as you may not have turned out the same way. This is theta. This is the angle it's plugging in. We're going to plug in 0 for the first one, 360 for the last one. You may have something different right now because when you hit graph, it may have looked that way. Theta step is how it goes in between points. So if you change this, now this is if you change this to 60 degrees, okay, basically it's going to plot it. It's going to hit at 0, 60, 120, 180. And if I hit graph, okay, it's going to look those are going to be straight lines because it connects between each point with a straight line on your calculator, because that's how it has to do it. To make sure it's a smooth curve, I usually use 5 degrees. Okay, if you use anything smaller than that, sometimes it even takes too long to graph. All right, X min is -10, X max is 10. To get a better view, you can change that. Basically, that's, going like your radiuses. I'm just going to go -5 to 5 so I can see it a little bit better. And now you got Y min and Y max. Okay, so we got 3 things we got to worry about. I'm going to do -5 to 5 as well. That just makes it a little bit bigger, a little bit easier to see. So you can see where it pinches in there and then comes back out. So there's your graph. And like I said, and now if you change this to like 1 degree, it just takes longer to graph because it's plotting every degree. So it's actually plotting 360 points to get to the end. And then here it comes back out for that. So like I said, 5 degrees is usually pretty good. And hopefully you're in degrees. Sometimes it'll pop up into radians and you want to change it back for that one. All right, so that was that first one. All right, the second one on your sheet there. We want to graph the polar 1 minus 3 sine of theta. I don't put it into your equation. Let's not do that yet. We are going to have to be able to graph from a table. Okay, so with or without your calculator. We still need to calculate these. So quit out of that, clear, and we're going to plug in. So we want 1 minus 3 times the sine of 0. And that is going to be 1. Because the sine of 0 is 0. So that is 1. And let me go back here. All right, what do we get when we plug in 30 degrees? You can do the old second entry trick. Make that 30 degrees. I get -0.5. All right, we did not have any negatives in the last one. Don't try to plot this just yet. Let's fill in this first line, and then we're going to go back. Okay, we're going to fill in this first line, and then we're going to graph these before we go to the second one. Okay, whoops, 1 minus 3 sine 45. -1.1. And plug in 60. negative 1.6. Let's plug in 90. Negative 2. All right, go ahead and plug in 120, 135, and 150. And then I'll just wait for you here. So plug in 120, 135, 150. So from 120, I got negative 1.6. 135, I got negative 1.2. And 150, I got negative 0.5. All right, I'm going to plug in 180 just before I graph anything. So I'm going to do second entry. And I'm going to get 180. And it gives me positive 1. All right, so the 0 is 1 and the rest are all negative. Let's graph these right now. Don't worry about the rest right now. Let's graph these because I want to get through here. Now, here's the issue. 0, 1 is right here. And where is 30, negative 0.5? Well, actually, technically, we would list it as negative 0.5, 30 degrees. Go to 0.5, 30, and then you go through the origin to the other side. Well, here's what you got to watch. You can't connect them like this. That's not going to be accurate. That's not going to work. So till you get a little bit better handle, let me go through something here. So that is 0, 30. So there is a lot going on between there. So actually what I want to do is I'm just going to kind of go to my calculator. And so we know 0 degrees. Let me flip that around. That's 0 degrees. What's happening at 5, 10, 15 degrees, 20, 25 degrees? I want to see that. Now, normally we're not going to do this, but since this is the first time, I'm going to go through this. So I got 1 minus 3 sine of 5 degrees. I get 0.7. Okay. 1 minus 3 sine of 10 degrees. I get 0.5. Second entry, make it 15. I get 0.2. It's getting closer to 0. And then second entry, 20. Negative 0.2. So hold on. Negative 0.02. So I'm just going to put that in there. And now let me erase that a little bit there. What about 25 degrees? And then second entry, 25, negative 0.3. And then we know what's going to happen at 30 degrees is negative 0.5. Now, normally we're not going to plot all these points, but I'm just getting the idea. So at 5 degrees, it is 0.7. Okay. And then at 10 degrees, it is 0.5. So it's hard to kind of estimate those. But what it does is it stays positive. Anytime it goes from a positive to a negative, it's going to have to go through 0. And it's not going to just go jump straight to there. So this is going to be a curve. So it's going to go through these points, and it's going to go through 0 to that point right there. Okay, so it's going to go above that x-axis. Let me see if I can draw that just a little bit nicer. Okay, through 0 to that point. And now we can kind of plot the rest from there, because what's going to happen at 45, I get negative 1.1. Okay, so 45 degrees, we go 1.1, basically it'd be 45 degrees off of this, and it'd be right there. At 60 degrees, you get negative 1.6. So go to 60, you go through there to negative 1.6. 90 degrees, which is right here, you get -2, which is going to be back here. 120 degrees, go through there, -1.6. 135 is -1.2, so we're halfway in between, or 1.1. I hope it's 1.1. Nope, I got 1.2. Is that the same? Did I screw something up? 1 minus 3 sine of 135. -1.1. Okay, I thought it had to be the same as the 45. And so that's right there. And then at 150, -0.5. All right, now here's what's happening. At 180, it goes back to +1, which is right here. So we're going to have to basically do that same thing. It's going to go through 0 back to that point. So I went through here, and then I want to connect these points. I go back through 0, and I'm to 180. So that's that first little figure. All right, go ahead. I'm going to pause this. You plug in 210, you plug in 225, you plug in 240 into your equation. Write it down to the nearest tenth, see what you get. Okay, I'm going to pause this. Okay, hopefully you went through there. Here's what I got. 2.5 for 210, 3 point. Now these are all positive. 3.1, 3.6, 4, 3.6, 3.1, 2.5. And I like to put 360 back. It has to go whatever 0 is 1. So 210 is 2.5. 225 is 3.1. 240 is 3.6. 270 is 4. 300 is 3.6. 315 is 3.1. And 330 is 2.5. And then back to 1. So when we finish this off, that is what it's looked like. Now, isn't that cool? Like that is like no other equation we've ever graphed before. It's not a parabola, it's not a hyperbola, an ellipse. These are a totally different shape. And that's the thing about polar grid graphs. You can get some amazing looking shapes from these. Now I'm going to go to my equation here. I'm going to type this one in. So that is 1 minus 3 sine of theta. Whoops, that doesn't do me any good. Go to y equals. Now, if you notice, when you're in polar form, it says r equals over there. And so I got 1 minus 3 sine of theta. And I graph that. And I said it went above there. So what I'm going to do here, just to kind of give you an idea, I'm going to really see if I can zoom in a little bit. I'm going to let my y max be 0.5. Okay. And you can't even see it. Let me see if I can do this even a little bit closer. So let's do this just so we can see that a little bit better. I'm going to just try and highlight that area. Maybe this may not work. Maybe it will. -1 and 0.5. All right, all I wanted you to see is how that does go above the x-axis there. It goes through 0. Okay, that's kind of that little area right in here. So that goes above here. It has to go through 0. There's a lot going on between these 2 points. Okay, that we got to be careful how we graph it. So there's a lot going on, and it has to go through 0 before it gets to that negative value. So that's what that one looks like. All right, those are the 2 graphs here. I'm just going to go through a couple of things here that aren't on your guided notes. You don't need to get these down, but this is just a little bit of the names. Now, this is called a lemicon. This basically, and we talked about the cardioid. So these are, sometimes you get the inner loop, and that was basically what we just did. That's part of this lemicon section. And then if A over B is less than 1, okay, so that was a 1 and 3. So this number is smaller. And it could be sine, so 3 sine of theta. You're going to get an inner loop. So let me just go back to here to show you. I'm going to go back to my window and make it -5 to 5. Okay. And so like if I make that 2 minus, let's see what happens here, 5 sine of theta. And actually, let me make it a plus. Okay, you get that inner loop, and that goes up all the way to 7 in that case. So you can just mess around with those numbers and get different things. Now, if A is equal to B, you get that cardioid look. So if I make this 2 plus 2 sine of theta, okay, that's where we get it, that inner pinch in. Looks like that heart. And now for, what did we get for cosine? It was to the right. This time it's straight up and down with the sine. And if I make it minus, what in the heck happens here? So you get all kind of different things. Now it's going to kind of be still vertical, but opened up down further on that case. So those are called lemnicons. And then of those, you got the inner loop and you got the cardioid. Also, we have cool things called Rose curves. So if n is odd, so basically you got a constant in front, and then you have a multiplier in front of here. If n is odd, it has n petals. If n is even, it has 2 n petals. So just take a look here. And if I just do, and basically that number in front will tell you it's how wide it is, or the radius. So if I make this say 3 cosine of 2 theta, okay, since that's even, it doubles the petals. You get, look at that. That's cool stuff. Okay. And if I make, if I make the cosine sine, let's see what happens on this, if anything. All right. See how it's kind of been rotated a little bit to the side? And if I go, see, if I change that number there, all it does is makes it bigger. Okay. It goes all the way to a max of 5. And let's see, what if I change this to 3 theta? Take a look at this. You get 3 leaves. And then now people get really crazy here. Here's where the artists come out. And so what if I make this 5 cosine of, let's see, 2 theta? What's going to happen here? And I graph them both on the same grid. So you can kind of get some cool different pictures. You can do all kind of different things here. Let me clear this one out. And then if I make this one 5 theta, okay, I'm going to get 5 leaves. An odd number, you get that number of leaves. An even number, you got to double those. You double the leaves. So in this case here, if I make it 4, you're going to actually end up with 8 leaves. Okay, so pretty cool stuff here with your polar graphs. And those are called Rose curves. Don't do a whole lot with these. These are called lemniscates. You can plug these. That's r squared equals, and then you got a constant. We don't deal a whole lot with those. And then you can also create spirals if you just take a number times theta. And let me just show you that real quick. And in order to make this work, you got to make this number pretty small. So if I do 0.1 theta, let's see what happens here. See, even gets too big, too quick. I think I got to make this like 0.01 theta. Okay, you can see it wrap around, and it'll keep spiraling. Now it only stops at after 360 degrees. To make that go around multiple times, you got to change that to like 720, and then it'll go around twice. But I think it'll go off of my screen. It goes around once, and it's going to go around twice, and you can keep going. So a lot of neat stuff you can create here, kind of like a reverse spiral here. A lot of different things. All right, all I'm going to give to you is you got 4 problems here. Graph the following. Okay, write down the chart from 0 to 360 like we did in the examples. So you got these 4 cosine 3 theta. Now these are going to be Rose curves, but you need to list the chart. Okay. Okay, and these are going to be like we did there, 2 plus 4 sine of theta, 3 minus 3 sine of theta. Now in here, let's see here. On the modules. And let's see here. Under this one here, the guided notes were from the day before because we continued on here, but it does have graphs for homework. So here is a PDF, and this might help you. There's 2 on each page, and then you can just use those. If you can print them off, if not, you can just do them on your paper, which is fine. You can go to you can find polar graph paper on the internet if you want to do that, but at least gives you something to work with, okay? So if you want to do that, that would be fine. All right, you guys have a great day. I'm going to close this video up here, and I will talk to you later.